Hello everyone, myself Aminata, and in operating system, let us discuss what is the concept of RAID. Okay, so this is the basic concept of hard disk technology. Okay, so RAID is a redundant array of independent disk. So RAID is a data storage virtualization technology that combines multiple physical disk drive components into a single logical unit for the purpose of data redundancy, performance improvement, large storage capacity, or all. So basically, this is the concept for the data storage virtualization technology. So it is combines multiple physical disk drive components. Okay. So data is distributed across the drives in one of several ways, referred to as RAID levels. So data is distributed in the several layers in several ways, and which is referred as RAID levels, which is depending on the required level of redundancy and performance. All RAID have the property that the data are distributed over drives to allow parallel operation. There are various levels of RAID. So RAID is a redundant array of independent disk. It is the concept for the data storage virtualization technology, which basically combines multiple physical disk drive components into a single logical unit. What is the reason for doing it? So the reason is data redundancy, performance improvement, large storage capacity. Okay, let us discuss its various levels. So the first one is RAID-0 stripping. What it actually do? So this is the concept that splits the data into blocks of data. Data means file. So strip the block across disk in the system. In the diagram to the right, the odd blocks are written to disk 1 and even block to disk 2. So the block 1, 3, 5, 7, these are written into disk 1. Block 2, 4, 6, 8, these are written to disk 2. It is easy to implement. Now no parity calculation overhead is involved. It provides good performance by spreading the load across many channels and drives. It provides no redundancy or error detection. So the concept is data or file is divided into blocks of data. The odd number of blocks is stored in disk number 1 and the even number of blocks are stored in disk number 2. But there is no concept or there is no technique for error checking and recovery. So this is not very good because there is no fault tolerance. So the failure of just one drive will result in all data in an array being lost. After a certain amount of drives, performance does not increase significantly and it requires minimum 2 drives to implement. So this is the disadvantage of this technique. The next technique, or we can say the type, is RAID-1 mirroring. Now, as the name suggests, the whole data is copied into this another drive. So the same to same data, which is mirroring. So a complete file is stored on a single disk and a second disk contains an exact copy of that file. It provides complete redundancy. Redundancy means duplication of the data. So the read performance can be improved. Same file data can be read in parallel, but write performance suffer as must write the data out twice. Most expensive RAID implementation it is because we have stored redundant data in the next, or we can say second disk. It requires twice as much storage space. For example, we have file of 1 GB. We have duplicate the same file in another disk, so we required 2 GB for the same file. So it required twice as much storage space. So this is one. This both disk drive 1 and 2 are equal. Block 1, block 1, block 2, block 2, block 3, block 3, and block 4 and block 4. So this both drive are redundant. But the advantage of this is, in case a drive fails, data do not have to be rebuilt, they just have to be copied to the same, or we can say that replacement drive. But the main disadvantage is that the effective storage capacity is only half of the total drive capacity because all data get written twice. For example, the total capacity of this is 500 GB, but we can only store 250 GB of data because of the data is written twice. Okay, so this is the level, or we can say that mirroring, RAID-1 type. The next is RAID-2, which is bit level stripping using a Hamming code parity. So in this, it strips data at bit level. In previous level, the data is stored as blockwise. Now what happened in here? Rather than block level, the data strips at a bit level with some disk storing, error checking and correcting information. It uses ECC error correcting code to monitor correctness of information on disk. A parity disk is then used to reconstruct corrupted or lost data. Imagine splitting each byte into a pair of 4-bit nibbles, then adding Hamming code to each one to form a 7-bit word, of which bit 1, 2 and 4 were parity bits. So there are total 4-bit nibbles, but to complete a form a 7-bit, there are 3 parity bits. Okay, so if data is corrupt or lost, parity disk is used to reconstruct them. So in RAID-2, each of 7 drives needs synchronized in terms of arm position and rotational position, and then it would be possible to write the 7-bit Hamming coded word over the 7 drives. But here losing one drive did not cause problem which can be handled by Hamming code. But in performance there is a problem that must have to read data plus ECC code from other disk. For a write must have to modify data, ECC and parity disk. So this is the disk 0, 1, 2, 3, 4, 5 and 6. Now here we write block A1, block A2, block A3, block A4, parity 1 for A, parity 2 for A and parity 3 for A. Same for the B, block B1, B2, B3, B4, B parity 1, 2 and 3. So this is how there is a 7 drives needed to synchronize in terms of arm position and rotational position. And we have write 7-bit Hamming code 1. Okay, so this is the concept of RAID-2. The next one is RAID-3, which is byte level stripping with a dedicated parity. It uses stripping and dedicates one drive for storing parity information. So this last drive is stored parity information to check whether there is an error or not, or to recover from the fault data. Here single parity bit is computed for each data word and returned to a parity drive. So this is block 1A, block 1B, block 1C and the parity. Same block 2A, 2B, 2C and parity. So the embedded ECC information is used to detect errors. Why this parity is used? To detect error and to recover from that error. As in RAID level 2, the drives must be exactly synchronized. As seen previously, this drive must be synchronized. Same in this this 4-DAR drive must be exactly synchronized. The next one is RAID-4 block level stripping with dedicated parity. It uses large strips, block level stripping, which means you can read records from any single drive. They do not require synchronization. So this is the difference in this. There is no requirement of synchronization of drives. RAID 4 is like RAID 0 with strip for strip parity written onto an extra drive. If a drive crashes, the lost bytes can be recomputed from the parity drive by reading the entire set of drives. This design protects against the loss of drive but performs poorly for small updates. Because if one sector is changed, it is necessary to read all the drives in order to recalculate the parity. So there block A1, block A2, block A3 and the parity for block A. Block B1, block B2, B3 and block BP, which is the parity. Okay, but it creates heavy load on parity. This is the block level stripping with dedicated parity. Okay, now the next one is RAID 5, block level stripping with distributed parity. Now this level is based on block level stripping with parity. So there is two types, either it is a block or it is a bit, block or bit. So this is block level stripping with parity. This parity information is stripped across each drive, okay, not in individual drive. As with RAID level 4, there is a heavy load in the parity drive. It may become bottleneck. So to remove that disadvantage, this is the concept that the parity information is stripped or distributed across each drive. Now this bottleneck can be eliminated in RAID level 5 by distributing the parity weights uniformly over all the drives. So this is block A1, A2, A3, block A parity. Now here block B1, B2, block B3, but here in disk number 2 parity is stored of block B. Like for block C, it's stored in disk 1 and in disk 0, block B parity is stored. So the parity is distributed across all the drive so that we can eliminate the bottleneck of the last parity drive as we have seen in the previous RAID level. Okay, so this is all about the concept of RAID. Okay, thank you.